In the realm of geological wonders, few discoveries capture the imagination quite like the world's largest geode. Nestled on the shores of Lake Erie in Ohio, this magnificent crystal cave, known as the Crystal Cave, is not just a testament to the Earth's ability to create natural beauty, but also a fascinating story of geological processes spanning millions of years. Discovered by chance in 1897, this Celestine geode continues to dazzle visitors and scientists alike, offering a unique glimpse into the planet's ancient past. The discovery of a lifetime. The story of the Crystal Cave begins with an unlikely protagonist, Gustav Heinemann, a German-American winemaker who had established his vineyard on South Base Island in Put-in Bay, Ohio. In 1897, while commissioning a well to be dug for his grapevines, workers made an unexpected discovery at a depth of about 12 meters. They had inadvertently broken through into a small cave adorned with enormous crystals. This serendipitous find would soon be recognized as one of the most significant geological discoveries in North America. The Crystal Cave is truly a marvel of nature, measuring more than 10 meters across. What sets it apart from other geodes is not just its size but the nature of its crystals. The cave is lined with massive Celestine crystals, some reaching up to a meter in width. Celestine, also known as celestite, is a mineral composed of strontium sulfate, typically presenting a pale blue color reminiscent of the sky, hence its name, derived from the Latin word for heavenly. A geological journey through time. To understand the formation of this extraordinary geode, we need to embark on a journey through geological time, spanning hundreds of millions of years. The story begins in the Silurian period, approximately 430 million years ago, when the area that is now northern Ohio was submerged beneath an ancient sea. Over millions of years, layers of sedimentary rocks formed at the bottom of this ocean, including shales and carbonate rocks. Crucially, between some of these layers, pockets of a mineral called anhydrite were deposited. Anhydrite, composed of calcium sulfate, is an evaporite mineral. It forms when seawater evaporates, leaving behind mineral deposits, a process similar to the formation of salt crusts, but on a much grander scale. These anhydrite deposits would play a crucial role in the eventual formation of the Crystal Cave. Fast forward to the end of the last ice age about 14,000 years ago. As massive glaciers retreated from North America, they sculpted the landscape, exposing the ancient sedimentary layers and creating the Great Lakes. This glacial retreat marked the beginning of the Crystal Cave's formation. The creation of the cave. As the glaciers receded, cracks in the exposed rock layers allowed water from the newly formed Lake Erie to percolate down into the ancient anhydrite pockets. This influx of fresh water began dissolving the anhydrite, creating cavities in the rock, the beginnings of cave systems. South Base Island alone is home to at least 30 such caves, a testament to the widespread nature of this geological process. However, the presence of a cave alone does not explain the formation of the massive Celestine crystals that make the Crystal Cave so unique. The key lies in the specific mineral composition of the groundwater that filled these cavities. The birth of Celestine crystals. The formation of the Celestine crystals in the Crystal Cave required a unique set of circumstances. First, the cave needed to be filled with mineral-rich water that couldn't easily drain away. As this water sat in the cavity over thousands of years, it slowly evaporated, allowing minerals to crystallize, a process similar to the creation of rock candy, albeit on a much grander and slower scale. The type of crystals that form in a geode depends on the specific minerals present in the water. In the case of the Crystal Cave, the process began with the anhydrite, calcium sulfate, already present in the rock. Over time, strontium-rich groundwater permeated the cave. This led to a gradual replacement process where the calcium in the anhydrite was exchanged for strontium from the groundwater, resulting in the formation of strontium sulfate celestine. A crucial factor in the growth of such large celestine crystals is the mineral's low solubility. Once the strontium sulfate began to crystallize, it remained stable, unlike the more soluble calcium sulfate. This allowed the crystals to grow unimpeded over thousands of years, resulting in the massive specimens we see today. Scientific studies have revealed that the Celestine crystals in the Crystal Cave grew over a period of several thousand years, beginning at the end of the last ice age and continuing until about 6,000 years ago. This prolonged growth period explains the exceptional size of the crystals, with some reaching up to a meter in width. A geological rarity, the crystal cave Celestine geode is exceptional for several reasons. Firstly, Celestine itself is relatively uncommon in geodes. Most geodes contain quartz-based minerals like clear quartz, amethyst, or chalcedony. The presence of Celestine indicates a unique set of geological conditions that are rarely encountered. Secondly, the size of the geode and its crystals is truly remarkable. Most geodes that people encounter are small enough to hold in their hands, often found in gift shops or mineral collections. The crystal cave, with its 10-meter expanse, dwarfs these common specimens, creating an immersive crystalline environment that visitors can actually walk into. Lastly, the purity and size of the Celestine crystals make this geode a subject of scientific interest. The crystals provide valuable information about the geological and chemical conditions present during their formation, offering insights into the region's ancient past. A living tourist attraction, more than a century after its discovery, the Crystal Cave continues to captivate visitors as part of Heinemann's Winery on South Base Island. The cave and winery have become intertwined tourist attractions, offering visitors a unique blend of geological wonder and viticulture. The preservation of the Crystal Cave as a public attraction is significant from both scientific and educational perspectives. It provides researchers with ongoing access to study this geological marvel, while also offering the general public a rare opportunity to experience the inside of a giant geode firsthand. This accessibility helps foster public interest in geology and earth sciences, making complex geological concepts tangible and awe-inspiring. Conclusion: the world's largest geode in Ohio's Crystal Cave stands as a testament to the Earth's capacity to create beauty through slow, patient processes. From its origins in ancient seabeds to its transformation by glacial waters and mineral-rich groundwater, the cave's history spans hundreds of millions of years. The result is a breathtaking display of Celestine crystals that continues to inspire wonder and scientific inquiry. As we marvel at the pale blue crystals of the Crystal Cave, we are reminded of the dynamic nature of our planet. The geode serves as a window into Earth's past, revealing the intricate interplay of geological forces that shape our world. It stands as a reminder of the hidden wonders that may lie beneath our feet, waiting to be discovered. The story of the Crystal Cave also highlights the often serendipitous nature of scientific discovery. What began as a simple quest for water for a vineyard led to one of the most significant geological finds in North America. It reminds us of the importance of curiosity and the potential for wonder in unexpected places. As the Crystal Cave continues to welcome visitors and researchers alike, it not only preserves a unique piece of Earth's geological history, but also inspires future generations of scientists and nature enthusiasts. In this giant geode, we find a perfect blend of natural beauty and scientific significance, a true gem in the world of geology.